Okay, so yesterday, when we did number 2, yesterday on number 2, you see I have a negative 2 on it? The base, not the exponent. Do you see what I'm talking about? Versus number 4, what do we notice about number 4? Okay, so since the negative is inside the parentheses for number 4, that means the whole thing goes inside my radical. Yesterday on number 2, remember I left the negative outside? Today, this negative can go inside. So before I take care of that negative, I'm going to take care of my negative exponent. Okay, and I'm going to turn this into 1 over negative 3 to the 1/2 power. Is that part okay? We're not doing anything too new? Okay, now this says write it in radical form. So how do I write that as a radical? Okay, I have 1 divided by, what's the root? What number goes down there? What number goes here? Why are you saying nothing? Because it's a square root. Okay, so before I put nothing, I'm going to write a 2. Is that okay? Do we understand that comes from the denominator of our fractional exponent? So that comes from here. And then inside is negative 3, and that's raised to the first power, which means I have 1 divided by the square root of negative 3. But remember, since this root is even, can I have like the square root of a negative number? No, if it's 2, 4, 6, 8, any even root, I can't have a negative inside. If it was odd, so 3, 5, 7, 9, etc., it's okay. But since it's a negative, what happens when you take the square root of a negative? You did that last year. I heard one of you say it. It's an I. Remember our imaginary numbers? So I have I radical 3. Now this is probably the only time you'll see it, but I did want you to see it in case it comes up again. Okay? We are going to skip 5 and 6. Those are you tries, but we're going to skip them because you'll do a lot of trying tomorrow. I have a whole worksheet for you. Okay? And we did 7 yesterday, so now we're going to move on to number 8. Number 8. Thank you. Okay, number 8. So we have the 5th root of 16 to the 1/3 power. So recall from number 7 yesterday, what do we do with number 7? How do we start that question? I put it in parentheses. What did I put inside parentheses, April? For number 7, what did I do? X to the 3/4 because that's all inside. So April, can you tell me for number 8 what I'll do? Good. Okay, do we agree this is all that's inside? 16 to the 1/3 power? Yes, sir. So I'm going to take that out and put it all into parentheses. And I'm going to move that 1/3 up a little bit. So that's all going to go into the parentheses. Now, I need to figure out what is the exponent that goes outside. What is the root of that fraction? 5. Good, because that's this number. And what is this number that it's being raised to? What's the power? 1. So what do I do to those exponents? What does the power rule tell me? To multiply normally. So I have 1/3. I do distribute, so that means 1/3 times 1/5. And I multiply across. What is 1 times 1? 1. And what is 3 times 5? 15. So that means I have 16 to the 1/15th power as my final answer. That's it. Because this one we leave it in exponential form. The next two, 9 and 10, I want you to try those ones. 9 and 10 are you tries. They are you tries. Hey, you should be trying these. Try 9 and 10, please. These are you tries. Let's check these answers for 9 and 10. Is this what you got?
Yes.
On number 9, if you had a to the 4/6, you need to simplify that, please. Because 4 times 1 is 4, 3 times 2 is 6, and 4 over 6 is 2/3. Are these ones okay? Ready to move on? Okay. Next set. And we're back where we started today. Okay, so now we're starting again. Okay, this says recall our product rule. What is my product rule? What does that tell me? I heard one person. It means we're multiplying. Yes, there's a multiplication sign. So what do we do to our exponents? I add my exponents. Good. Okay, so for number 11, there are a couple of ways we can do this problem. I'm going to show you one way first, and then I'll show you the second way second, and then you can decide which one you prefer, and we'll talk about the benefits of one over the other. So for number 11. Okay, so back to our math. I have the cube root of 2 squared times the cube root of 2 to the 4th power. I want to turn these, for my first method, I want to turn these each into fractional exponents. So for my first one, I have 2 to the what power? Let's focus. I'm up here. You don't need to be looking at the back of the room. 2 to the what power? 2 to the, what's my root? What's my root? I'm waiting for you all to say it because I heard 2, 3, and 4. I'm not convinced you know. What is the root? Okay, good. What is the power? 2. Do you all follow so far? Okay. Now for the second one, what is the root? The root. The root. Thank you. And what is the power? Okay. Are we back on track now? Okay. So you guys told me add them. So I have 2 to the 2/3 plus 4/3. What is 2/3 plus 4/3? How come I can just add them? They have the same denominator. Good. So I have 2 to the 6/3. And what is 6 divided by 3? 2. And what is 2 squared? 4. So that would be my final answer, okay? I'm going to show you a second way, okay? And I'm going to write that second way in red. So do you see how both of these radicals have the same root? They're both a cube root. Okay, so that means I can make one gigantic cube root and put both parts inside it. Do you understand what I've just done? Okay. I went from having 2 separate radicals to one radical together, and now I'm going to combine what's inside. I can follow the same rules and say I have the cube root of 2 to the, what's 2 plus 4? 6. So now I have the cube root of 2 to the 6th power. And how do I write that as a fraction? 2 to the... 3's at the bottom, okay. And 6 on top, so I get 2 to the 2, which is 4. Okay? This way, please look. Yeah, I like this way better. But it only works if the root is the same. So on number 12, can I do the red way? No, why not? Because the roots are the same. So the black way will always work, whether or not the roots are the same. But sometimes the red way is a little bit faster if I do happen to have the same root, okay? So for number 12, I have a 4th root, and what else do I have? A 5th root. So those are 2 different roots. So can I do the red way? No, I have to do it the first way. I have to turn it into exponents, a fractional exponent, and then solve. So I have b to the what power? 3 over 4. Hello? You awake? You listening? You sure? The second one, come back, is b to the what power? 5 over 5. Okay, much better. Good. Now, what is 5 divided by 5? 1. Can I simplify it here? Yes, I can. But I don't like to because I know I have to add 2 fractions together and I'm going to have to give the fraction anyway, so I'm just going to leave it until the final step, okay? It might make it easier, but I think leaving it will be better for now. So since we're still using the product rule, I'm going to add. Can I just add as is? Do they have the same denominator? No. So that means I need to find a common denominator. And Danielle says it's what? It's 20. Do we agree with her? Yes, I agree. So what do I need to multiply each of those things by? I need to multiply good by 5 on the top and bottom, and by 4 on the top and bottom. So what is 5 times 3? Good. 5 times 4 is 20. And then 5 times 4 is 20 over here. So what is 15 plus 20? 35 over 20. And now, can I simplify 35 over 20? Yes, I'm going to divide each by 5. So I get 7. 7 over 3. 7 over 4. Okay, so that is my new exponent. So I have b to the 7/4 power as my final answer. Does that make sense? Okay, now finally I have number 13. Before you try, I have number 13. Okay, on number 13, can I use the black method for number 13?
The black.
The one that I wrote in black. Can I use the red method for number 13? Yes. Why can I use the red? Why can I use the red method for number 13? Because what's the same? The root. And what is the root? If it's nothing, nothing's there. That number is 2. Yes. If there's no number there, I'm going to write it 2. Okay. So do we want to do it with our fractional exponents or combine the radicals? Hello. Focus, please. Okay, do we want to combine or use exponents? Okay, so I'm going to show you exponents. I'll actually show you both. It's pretty fast. So if I'm doing exponents, each of the things goes into parentheses. I'll show you the other way in a minute. And then this is where you guys like to say distribute. So that means this gets to all of those parts, okay? So I have 4 to the 1/2 times y to the 3/2 times 4 to the 1/2 times y to the 5/2. Does that make sense? Okay? Because each of those 4s has an exponent of 1. Okay? And when I multiply them, 1 times 1/2 is 1/2. 3 times 1/2 is 3/2. Okay, so 4 to the 1/2, that's the same as saying the square root of 4. What is the square root of 4? 2. So I have 2y to the 3/2 times another 2y to the 5/2. Okay. So that gives me 4 because 2 times 2 is 4. And then 3/2 plus 5/2 is 8/2. And what does that simplify to be? 4y to the... What's 8 divided by 2? What's 8 divided by 2? Ooh, this is making me very sad. Yes, it is 4. Okay. 2 of you. I have 30 some, however many of you there are. Okay. Yes. Which last part, Danielle? Right here? Okay. So the square root of 4 is 2. Right, the square root of 4 is 2. And then I just bring down the y. And then I have the square root of 4 again, which is another 2. And then I bring down that y.
Wait, why do you have the square root? Yeah, why is the square root?
Because 4 to the 1/2 is the square root of 4.
Oh! Oh.
Because this, remember, is 2, 4 to the 1, which is the square root of 4. Okay, does that make sense? Is that where your confusion was?
Yeah.
Okay, now for the other way, those of you who like the other way better, here we're going to make a big square root. That is way too big.
Oh, that's the one that the shorter one?
Yes. So since they have the same root, focus, please. Okay, what are my like terms here? 4 and 4, and what else do I have? Y and y. Okay, so what is 4 times 4? 16. And then how many y's do I have? I have 3 and 5, so I have 3 plus 5 is 8. Good. Okay. So this is like saying the square root of 16 times the square root of y to the 8th. I don't have to break it up like that. I'm just doing it to show you. What is the square root of 16? 4. Thank you, April. And what is the square root of y to the 8th power? Thank you, Diego. What is the square root of y to the 8th power? How many times does 2 go into 8? 4. That's how I get this. My stylus is being dumb again. That's how I get that as the answer. And they're the same. It's just two different methods. Okay? Yeah, so the red way can be a lot easier if the roots are the same. But the black method, the one I wrote in black, that will work no matter what. The red way only works if the roots are the same. Can you do the next three you try, please? Okay, you don't get 5 minutes. You get 30 seconds. Because we have less than 10 minutes left and I have a lot to do still. Here are your answers. Okay, on number 16, if you tried the method that I showed you and you got 4 to the 1/3 power, that is also correct. It is 9. No, it is 9. Okay, on number 14 is 9. Shh. I showed you most of the work for that. Number 15, you need to find a common denominator, which is 6. I'll wait. Number 16, you could either do it the way I showed you by combining it into one radical or by turning each into an exponent. If you combine it into a radical, you likely had 4 to the 1/3 n squared. But remember, 4 is just 2 to the 2nd power, so that's how we got, 2 to the 2/3 power, which is the same as 4 to the 1/3 power, okay? I'm moving on. If you need help, you need to come get it at some other time. Okay, finally, we have recall the quotient rule, backside of your page. Okay, quotient rule is when I'm dividing, what do I do to the exponents? When I divide, what happens to the exponents? Come on. Subtract. So I have 8 to the 4/3 minus 1/3. What is 4/3 minus 1/3? Good. I have a common denominator. So what is 8 to the 3/3? Can I simplify 3/3? Yes. To what? 1. So that means the answer is just 8. That's this final answer. Okay? Sometimes it does that. Let's look at number 18. Okay. 18 has the same steps. N to the 2/3 minus 1/4. Can I just subtract it right away like I did before? No, why not? Yeah, I need a same denominator. So I have 2/3 minus 1/4. What is their least common denominator? 3. It is going to be 12. So I need to multiply by 4. And I need to multiply by 3. So I get 8 over 12 minus 3 over 12. Do you agree with that? Yes. What is 8/12 minus 3/12? Oh, it's minus. What do I get? 5. Good, 5/12. Okay, so that means my answer is going to be n to the positive 5/12. What if I had a negative for that? What if I had...
Can't do it.
Why can't I do it? If I had n to the negative 5/12, this isn't the answer. Okay. But since I have this negative, that means I turn it into a fraction and make it positive like that. Is that okay? Okay, I'm going to do the last one with you, and then we have you tries, and we'll be done. Number 19, what do you notice about 19 that's different than these two? It has a radical and it has an exponent, so we're putting both together. So, what I'm going to do is turn this radical into an exponent first, so help me out. I have 2 to the what power? 4 divided by 3, all divided by 2 to the 2/3. Now that I have 2 fractional exponents, I can subtract them. What is 4/3 minus 2/3? Yeah, it is 2/3. I have a common denominator, so I can just subtract. And that is the final answer. Okay, can you do the U-tries? You have 3 minutes. Work on them, please. Do the U-tries. Let's go. The U-try should be pretty quick. If you have a negative exponent, it's okay. You just need to use your negative exponent rule. Okay, I'm going to give you 1 more minute before I put these answers up. And then at the beginning of class tomorrow, I will do the next 3 and then give you the rest of the time to practice. Let's check these. Here are my answers. Is that what you got? Yep. Okay. Please check your answers. You will be assessed on this soon. If you need help, come get help from me.